All right, welcome to day 4 of distance learning. For geometry, we are going to spend today, Tuesday, April 7th, and then again on Thursday the 9th, finishing up our unit reviews. So you know we have spring break coming up next week, so you have a week off. So please find something to entertain yourself, enjoy your time away from here, or catch up on some work that you're missing. But that means right after April break, we're going to start looking into our new unit. So this unit review is on transformations, and we really focused in on 4 different types of transformations. So translation, right? Moving our graph left and right, it's a shift or a slide. Reflection, where we can actually reflect, right, when you're looking in a mirror, over the x-axis, the y-axis. We talked about the line y equals x. We're going to rotate figures, 90 degrees, 180, 180 degrees, and then 270 degrees. And remember, we focused on counterclockwise. And then the last one was dilations. So we are making a figure either bigger or smaller, right? Depending on our scale factor. So I will be posting a link to the cheat sheet that we looked at in class. So if you don't have your notes with you, I will be posting that into our Google Classroom today so that you have that to look at. And I have this nice coordinate plane so that we can look at some graphs together. But just to refresh, so translation, right? If we have the point x comma y, we are either going to be adding or subtracting from the x value, or adding or subtracting from the y value, and that's going to create that shift that we're talking about. The x-axis controls left and right movements. So if it's a plus sign, you'll be moving to the right. If it's a minus sign, you'll be moving to the left. So for example, if that x value were 5 and we were subtracting 3, then we're actually moving to the left 3 units. Good refresher. Same thing with the y's, except the movement is either up or down. If that y value were 10 and you added 4 to it, it is actually going to be at 14. So it's shifting the graph up 4 units. Now you can actually have 2 different movements at the same time, either left or right, and up or down. So you can slide left and right or shift up and down at the same time. Reflection. The 2 we're going to focus in on this review is going to be talking about over the x-axis and over the y-axis. So if you are reflecting over the x-axis, your x value actually stays exactly the same, right? This is the x-axis, so we're going to be folding this paper, folding our graph in half, right at this x-axis. That would be our line of reflection. And that means any numbers that were above it would end up below it, or any points that were above it would end up below it, and any points that were below it would end up above it. And so we're actually going to reflect this one now. So we are reflecting this over the x-axis, which means, again, our x values are going to stay exactly the same. It's our y values that's going to become the opposite. So that's going to affect how we shift our graph from the top to the bottom. So if my original point was at 2, 5, so 2, 5 is our original point, but we are reflecting over the x-axis, my x value is going to stay exactly the same, but my 5 is now going to be -5. So my new a value is going to be at the point 2, -5. Same thing happens with b. If that point is at 6, 3, my new point is going to be at 6, -3. And then lastly, c over here at 4, -1. My x value of 4 will stay the same, but -1, remember the opposite of -1 would now be at +1. So now that I have my 3 new points, I can reflect this figure. So if my original point were at 2, 5, my new point is at 2, 1, 2, -5, 1, 2, 3, 4, 5. Here is a prime. And if I plot my new point B, it was at 6, 3, but now it's at 6, -3. Here's B prime. And then lastly, C was at 4, -1. Now it's at 4, +1. And again, I can connect my points. And you're going to notice that our shape hasn't changed at all. That triangle is still the exact same size, it's just been reflected over our x-axis. So that's a little review on reflections. And then again, if you need to hit pause at any time and write down our little cheat sheet, I will bring this closer to you. So this is what happened with our x values. If they were at 2, 5, My new point was at 2 comma negative 5 because of that rule. My x value stays exactly the same. My y value becomes the opposite. Okay, so we're going to erase our new graph. And this time we're going to look at a rotation. So I'm going to keep my original image. Okay, and I'm going to throw this up here. And then the last set of notes we're going to refresh on are rotations. And this is the one that we had the most trouble with. So we're going to take our time here. So remember, we're always talking about counterclockwise, right? If we want to look at clockwise, we can reverse the order of these, but don't worry about that. So if we are rotating counterclockwise, meaning the opposite way of the clock rotating. So for starting here, we're looking this way, kind of how we count the quadrants. And we are starting in quadrant 1, we should end up moving one quadrant over for 90 degrees, which is what happens here. If my point were at the coordinate x comma y, to rotate that 90 degrees, you're going to switch the x and y value, but that y value has to become negative. So again, if you started over here in all the positives, you need to end up over here, which is where your negative y values are. So 90 degrees, you're switching x and y, the order, and you're making your y value negative. For 180 degrees, if you were starting in quadrant 1, then your figure would end up down here in quadrant 3, where all the negatives live. So negative x values, negative y values. So if it were a positive x value and a positive y value to start with, your ending point would be at a negative x, negative y, same order. So that point just becomes negative, or each coordinate in that point becomes negative. And then lastly, 270 degrees, if you have your point at x comma y, you should end up in the 4th quadrant, and that's where your x and y values reverse, or your x and y values switch signs, but then your y value, your x and y values switch positions, and your x value becomes negative, okay, in the second part here. So again, we're looking at the positive of a new x value, and we're heading down. So we are going to look at a 90-degree rotation with the same graph that we've already had. So again, these 2 points are in the 1st quadrant, so we know they're going to end up in the 2nd quadrant. But this point down here is in the 4th quadrant, which means it's going to end up in the 1st quadrant. Everything's rotating one quadrant counterclockwise. So before we do anything, we need to figure out where our new coordinates will be. So again, if our point starts off at 2 comma 5, and my rule for a 90-degree rotation is to switch the position of x and y, but make y negative, then my new point will be at the point negative 5 comma 2. So I've switched the position of the 2 and the 5, and my 5 became negative. So far so good. We're going to do the same thing with b. We're going to switch the position of 6 and 3, but 3 is going to become negative. So negative 3 comma 6 is our new coordinate for b. And then lastly, we're going to switch the position of 4 and negative 1, but our rule was negative 1 needed to become negative, but if negative 1 is already negative, then that now is a positive 1 comma 4. So we now have our 3 new coordinates, which we can plot. And again, a quick check. A and B should end up in quadrant 2, and C should end up in quadrant 1. So let's see what happens. My new point of A is at the point negative 5, 1, 2, 3, 4, 5, comma, positive 2. My new point B is at negative 3, 1, 2, 3, positive 6, 1, 2, 3, 4, 5, 6. And my new point C is at the point 1 comma 4. 1 to the right, 1, 2, 3, 4. And before I go and play connect the dots, A and B ended up in quadrant 2. C ended up in quadrant 1, which is what I was thinking should happen. And now if I played connect the dots, I should end up with the exact same original shape, but it's rotated. So we can take care of translations, we can take care of reflections, rotations, all by deciding or using the correct rule for our coordinates. So again, if you need to freeze the frame here at your rotation rules, do so you can write them down. Or your translation or reflections, you can freeze this and write them down. And then the last one we were talking about was dilations, and that has everything to do with your scale factor. So if you are multiplying your coordinate by a scale factor that's bigger than 1, your figure should be getting bigger, right? It should be an enlargement. However, if you're multiplying your coordinates by a number between 0 and 1, then that figure should be shrinking. So you should have something that's getting smaller as you go. So I'm going to post this cheat sheet into our Google Classroom so you can use it along with your practice. Your quiz is going to be loaded up. You can just follow your password to get in or the code to get in, and then you can email me with any questions that you may have. Okay?